Now, in this lecture and the next few lectures, I want to start talking about man-in-the-middle attacks. These are attacks that we can launch only if we are able to intercept the communication between two devices. Hence the name man-in-the-middle attacks. So, a normal communication would look like this, where the device is directly communicating with the entity that they want to communicate with. In a man-in-the-middle attack, the hacker would be able to place themselves in the middle of the connection, allowing them to intercept and see anything that is being transferred between the two devices. Now, there are a number of ways to achieve this. The first method that we'll cover in this course is using an ARP spoofing attack. ARP spoofing allows us to redirect the flow of packets, so instead of it flowing as shown in this diagram, it would flow through my own computer. So any requests sent and any responses received by the target computer will have to flow through the hacker computer. This means that any messages, any websites, any images, any usernames, any passwords entered by the target will have to flow through my computer. This allows me to read this information, modify it, or drop it. So as you can see, this is a very serious and very powerful attack. And the reason why it is possible is because ARP is not very secure. Now, for us to understand how this works, you need to have a basic understanding of what ARP is. ARP stands for Address Resolution Protocol, and it's a very simple protocol that allows us to link IP addresses to MAC addresses. So, for example, let's say we have a network here. We have devices A, B, C, and D. They are all connected to the same network. And we have the router here for this network. We can see that each device has an IP and a MAC address. And let's assume that device A needs to communicate with device C. Now we're also going to assume that device A knows the IP of device C, but as we know so far, in order for these devices to communicate within the same network, device A needs to know the MAC address of device C, because like we said before, the communication inside the network is carried out using the MAC address and not using the IP address. So this is a perfectly normal situation where we have a client that needs to know the MAC address of another client so that it can communicate with this client. So what this client does, it uses the ARP protocol. What do I mean by that? Basically, it sends a broadcast message. So it sends an ARP request to all the clients on the network saying, who has 10026? Now, all of these devices will ignore this packet except the one that has this IP address, which is 10026, which is device C. So all devices will not do anything. And the only device that will respond is device C, sending an ARP response. In this response, device C is going to say, I have 10026, my MAC address is this MAC address. This way, device A will have the MAC address of device C, and now it will be able to communicate with device C and do whatever task that it wanted to do initially. So all of this communication is facilitated using the ARP protocol. Like I said, the ARP protocol is a very simple protocol. As you can see, all it has is requests and responses. And the whole point of it is so that we can link IP addresses to MAC addresses or translate IP addresses to MAC addresses. So a device can send a request asking for a MAC address, and then the device that has the MAC address would respond with its MAC address. So each computer have an ARP table which links IP addresses on the same network to their MAC addresses. So if I go on the Kali machine and do ARP-A, you can see my ARP table here, and as you can see, it's linking the router's IP to the router's MAC address. Now same if I go to the Windows machine and run my CMD and do ARPA, you'll see again it's linking the router's IP to its MAC address. So this machine, anytime it needs to send any request to the internet, it will direct that request to this MAC address, to the MAC address that's associated with the IP of the router, which is 10.0.2.1. Now, this value in here can be easily modified by exploiting the ARP protocol. So let me go back to my diagrams. And right here we have a diagram of a typical network. And you can see that normally any device that's connected to the network, if it wants to send requests, it will send them to the router. The router will go and send that request to the internet, wait for the response, and then forward the response to the device that requested it. So if the hacker or the victim or any other computer on the network wanted to send a request, they will send that request directly to the router. Now what we can do is we can exploit the ARP protocol and send two ARP responses, one to the gateway and one to the victim. We're gonna tell the gateway that I am at the IP of the victim. So the access point will update its ARP table and it will associate the IP of the target with my MAC address. We'll do the same with the victim, so we'll send it an ARP response. We're gonna tell it that I am at 10.0.2.1. So it's going to update its ARP table and associate the IP of 10.0.2.1 with my own MAC address. So the result of this, the victim is going to think that I am the router, and the router is going to think that I am the victim. So anytime the victim wants to send any requests, the requests will have to flow through my computer, and I'm going to forward them to the router. And then anytime the access point or the router wants to send responses, they're going to go to my machine because it thinks that I am the victim, and then I'm going to forward it to the victim. So as you can see, this puts me in the middle of the connection and it gives me so much power, and we'll see all the things that we can do once we become the man in the middle. Now, the main reason why we can do all of this is because ARP is not secure. Because first of all, clients can accept responses even if they did not send a request. So as I said before, we're going to send a response to the access point and a response to the victim, telling them that I am at a specific IP, without them asking who am I, or without them asking for this IP. I'm just going to send a response and they're going to accept that response anyway. Not only that, but they're also not going to verify who I am. So when I say that I am at 10.0.2.7, I am clearly not at that IP because this computer is at this IP. But the access point will trust this and it'll actually update its ARP table based on the information that I send. Same goes to the victim. I'm going to tell it that I am at 10.0.2.1. It's going to trust and believe this even though I am clearly not at this IP because the access point is at this IP. So these are the two main weaknesses with ARP protocol that allow us to run ARP spoofing attacks.